Port harbour has played an important role in a country's economy. And following the trend of technology, port functions are transforming from fully man-powered execution to automated systems, which they now call it a smart port. With a new generation of computer network, 5G, it is an enabling technology for building a smart port or harbour cities. So today, we are going to discuss about how 5G is the technology to build a smart port.
A smart port is an automated port that uses technologies such as big data, Internet of Things, artificial intelligence, and other smart technologies based on methods to improve performance and economic competitiveness. With these technologies, smart ports can also improve environmental sustainability. All these technologies combined, it helps to make the best decisions and improve the efficiency of a port. A smart port should not be considered a mere application of digital technology, but the intelligence of a port is also based on its ability to develop a collaborative approach. An example of smart port is the Port of Hamburg, which has implemented sensors, camera systems, and smart lights on the roads in order to monitor traffic, anticipate the lifting of bridge, or clear the road after an incident, facilitate the movement of barges when the traffic is saturated, etc.
5G or fifth generation technology is the latest system of mobile communications which aims to provide higher performance, reduced latency, and greater user density compared to the previous generations of 2G, 3G, and 4G. It has the following properties which consist of millimeter waves, small cells, massive MIMO, beam forming, and full duplex. Millimeter waves are waves with a small size wavelength of between range of 10 millimeters to 1 millimeter. It loses transmission distance in exchange for a larger bandwidth. This makes it ideal for small and targeted deployments like a small port. Small cells are small portable miniature base stations which consume minimal power and are placed at specific distances to maintain the signal throughput over the coverage area. Massive MIMO, also known as massive multiple input, multiple output, is the grouping of antennas at the transmitter and receiver to provide better throughput and better spectrum efficiency. It allows the ability to multiply the capacity of the antenna links. Beam forming is a traffic signaling system used by cellular base stations to identify the most efficient data delivery route for a particular user on the network. It also has the added benefit of lowering interference for nearby users in the process. Full duplex technology allows the transceiver to transmit and receive data at the same time and on the same frequency. This essentially doubles the capacity of wireless networks on their most fundamental physical layer.
Some of the smart ports have utilized the use of 5G. In Qingdao Port, 5G has been used for purposes such as HD cameras and ship-to-shore, which is STS, container cranes. With the millisecond level latency, control signals of 5G, the port is able to function in the fastest way possible. This is because low latency provides real-time interactivity, which made everything more precise and accurate. The high bandwidth improves the transmission rate and causes traffic intensity of the network to become closer to zero. As the traffic intensity approaches zero, there will be less congestion, which allows data to be sent at the fastest speed possible. HD cameras are able to capture the precise shapes, movements, and characters of a ship and containers, then send it back to the control room for workers to remotely control vehicles and machines. With these functions, workers of the smart port can control the flow of moving containers faster. Other than that, Port of Hamburg uses network slicing to partition 5G into two networks. One is for transferring large data such as video applications. The other one is to process data such as environmental data in real time. This is like frequency division multiplexing, where it divides the total bandwidth of a dedicated connection. For you to have a better understanding, let's look at this example. 5G has a frequency up to 300 GHz, and frequency division multiplexing divides the frequency into a few series of smaller frequencies, which they cannot overlap and can be allocated for different connections. So, each of the frequencies can be used for different devices and be accessed by control room.
Smart pods mainly use peer-to-peer architecture, as the machines, gadgets, and control center can communicate with each other directly. The advantage of this peer-to-peer architecture is that it is inexpensive, as smart pods do not need to set up servers for it. Furthermore, it has a self-scalability function, where new devices that join the network will provide additional resources, such as network bandwidth. As 5G has a full duplex connection function, it is useful for machines in SmartPod to send data to the control center for processing and send it back to them so that the machines can perform faster and more accurately.
One of the most sought-after use cases of 5G is the rapid influx of IoT devices that will benefit from the technology. Almost everything can be connected to a network, allowing for implementation of sensitive applications that require immediate and consistent reception of data. In the context of a smart pod, there are countless devices that may benefit from IoT, such as ship-to-store container cranes, which carry shipment crates. However, with such a large increase in the number of nodes connected to the network, the present network technologies will not be able to accommodate it without costly implementation of additional infrastructure. One of the main technologies that drives the 5G cellular network technology is massive MIMO, or multiple input, multiple output, which in one study has said to increase the user capacity by 22 times through utilization of as many as over 100 ports, with each port having antennas used for communicating with nodes connected to the network, compared to the current 4G technology that uses 12 ports. Following this improvement, however, there would still be the problem of interference by introducing so many devices to the network, the situation being analogous to adding a new lane to a highway, but then significantly increasing the number of cars that take that highway. Another main technology of 5G, known as beamforming, tackles this problem made worse by massive MIMO. Beamforming works by having transmitters focus the signal directly to the node it is connecting to, rather than simply broadcasting the signal. Standard beamforming may solve the interference problem, but only perform this at a horizontal level. But 3D beamforming allows this to be used on a vertical level as well, thus making possible a direct connection between a base station and a node or transmitter on the top floor of a building.
In Old City Harbour, Port of Tallinn has created a smart pod that assists traffic management. The added number plate recognition system, barrier gate automation system, display system, and many other sensors to smoothen the traffic in that port. We believe that if they convert that smart pod into a 5G smart pod, it will be extra beneficial for them. The massive MIMO technology of 5G would help to prevent bottleneck link where the data to be transferred is larger than the link capacity, which causes longer end-to-end delay. Hope you guys enjoyed the video, and if you have any questions or any suggestions for us, please leave it down in the comments below, and we'll try our best to respond to every one of you. Thank you guys for watching.